Yep.
No, we add.
I will add in as much time as you want, okay? So this is November 17, the mock that the M5 did just after Christmas. We're going to start off with question 1 and work our way through. Code is A, B, C, 1, 2, 3. We're starting at question 1, Jen, okay? All right, so starting on question 1, we have got the set of natural numbers n and the set of integer numbers z are represented in the Venn diagram below. Label the Venn diagram by placing the draggable numbers provided into the correct location. Okay, so these are our draggable numbers. What is a natural number? All right.
It's a number plus integer.
Right. Good. What is an integer? Right, negative or positive whole numbers. Okay, so we need to put these into this diagram at some place. So the first one, 49 to the power of a half. If something is to the power of a half, what does that mean, Kate? Square root. So the square root of 49 is 7. So is it a natural number or an integer? It's a natural number. It's also a integer, which is why the natural numbers are a set within the integers. 12 over 3 is 4. It is also a natural number. What about the square root or negative the square root of 9? Right. It is an integer. Is it a natural number? No, just an integer. And then what about this funky looking one? It's none of the above, okay? Remember, we can't take the square root of a negative number, okay? We would get what is called a complex number. Okay, now for that you need to get all 4 correct to get 2 marks, okay? Has everybody got it on their paper? Like, why don't you plug in over here, guys?
Okay.
So remember, you need to have 4 correct to get 2 marks. You need to have 2 correct to get 1 mark, okay?
Can I set up right here?
As long as you can see.
Okay, because I don't want to block it again.
We're recording this, so we want to go quick. Otherwise, it's going to be very boring. Right, the next part, we've got now rational numbers. What is a rational number?
It can be put as a fraction.
Okay, a rational number is a number that can be written as a fraction, okay? So first off, so if I put all these back, what is R stand for?
Real.
R are real numbers, okay? So any number that is not complex, okay? So it can be anything. Let's do the first one here. What is log 1 to the base 2? Okay, so thinking
0. Yeah.
it is 0 because remember you think 2 to the power of what number is equal to 1, okay? When you write it in terms of exponent form, 2 to the power of what is 1, that is 0. So that means it is a natural number. Okay, what about this negative the square root of 7?
Real.
It's definitely a real number. Can it be written as a fraction?
No.
Nope, so it has to go in the real part. Okay, this one's nice and easy because it is written as a fraction, so where's that going to go?
Rational.
Okay, rational, Q. What do these 2 little lines mean in this one?
Absolute value.
Absolute value, right. What does absolute value mean?
No, it's just always a positive.
It's always a positive. So you think of the absolute value as the distance something is from 0, okay? So negative 4, how far is that from 0?
4.
4, okay? So the absolute value of negative 4 is 4. The square root of 4 is 2, which is a natural number. Tan of 30, this is one that you need to remember from your exact values. Tan of 30. Okay, so which triangle are you thinking of?
30 and 60.
30, 60, which has got a 1 on the bottom, 2 root 3. So tan of 30. Opposite, which is root 3 over 2. Right, good. So is that
Real.
it? It's a rational number, root 3 over 2?
Yeah, that's
Oh wait, is that the fraction?
It's a fraction, but is root 3 a
Oh.
rational number?
So
No,
it's real.
real.
So it's real, okay? And pi, of course,
Real.
is a real number because it goes on forever, cannot be written as a fraction, okay? Any questions on those? Okay, we dropped quite a few marks there. This one I'm going to leave for a minute because I want us to I want to come back to it. I wouldn't put that there. Basically what we're saying here, I would say that if you're in N or in Z, okay, either two of these, they are a subset of Q, okay? So these two are a subset of Q, okay? All right. Over onto question 2. So given that f of x equals square root of x minus 4, g of x equals this, show that f of g of 7 is equal to 3. Okay, some of us did this different ways. One particular way you can do it is you can work out first off what g of 7 is. Okay. And I am in caps, so there we go. G of 7 is equal to 2 times 7 and then take away 1. 2 times 7 take away 1 is 13. Now I need to do f of,
You have to do the G into the F.
right, so it's f of what though?
13.
F of 13, because it's f of g of 7. So I'll put that in actually. F of g of 7, that's the same as f of 13, which is, now I'm going to use the equation editor here, which is this one. So I want the square root of 13 minus 4. Which equals the square root of 13 minus 4 is 9, which equals 3, as required. Okay, this is the type of thing, wow, that's come out nice, hasn't it? That we need to make sure that we're getting, wow, put in nicely. So can I put, there we go, okay. Now you could work out what f of g of x is as a function and put everything in. Either way, it doesn't make any difference, okay? Is everybody okay with that? Yep. Looking on to the next one. Given that f of g of a equals 4, find the value of a. Right. What I'm going to do is, can I copy this? Can I?
Yeah, you have to use the command. You have to do Control C, so you underline it, then do Control C.
No, it doesn't like you.
It didn't let you?
Yeah, it's letting me.
Is it letting you highlight it?
Yeah.
I can
Why is it not letting me highlight it? Okay, well,
it lets me.
Oh no, it doesn't. Not for that. For all the other ones.
right, so f of g of a.
Because that's like a picture.
Now this is where some people slipped up, okay? So what I'm doing is I'm putting g of a into f. I'm putting this into here, okay? So I've got the square root of, if I just go back up to check, so this part is going into where x is, yes? Because it's f of g of a. So it's the square root of 2x minus 1, or it's going to be not 2x, but 2a minus 1, and then also subtract 4. Is everybody okay with that?
Yes.
This part here is essentially my x part. Now, this is equal to what? 4, okay? Now, you need to put that it's equal to 4 to ensure that you get 2 marks in this question, okay? You get a minimum of 2. Okay, you get 1 for substituting your g of x in. You get 1 for it equaling 4, okay? Right, how do I go about solving this? What would you do first, Samara? Anything at all. Okay, now this -4 is underneath this square root sign.
I would square it.
Okay, I'd square both sides, so I get 16 equals 2a minus 1 minus 4. Then, right, so how do I take the -4 to the other side? Add it, right. So I get 16 plus 4 is 20 equals 2a minus 1. Then, good, 21 equals 2a. A equals 21 over 2. Good. And I've done all of that in the equation editor, okay? And again, I don't like how this is set it up, so I'm going to put all that just underneath.
Do you have to use the editor? Once you get past the square root, do you have to use the editor?
I find it's easier to use the editor because you just do it all in one go, okay? Rather than going back and forth, okay? So I just typed all that in using the editor. Has everybody got it? You okay, Jordan?
Yep.
Any questions on question 2? Like you can see, that's already 11 marks. These are 11 easy marks, yeah? So we're more than halfway to a 2 already. All right? All right.
Yeah.
Question 3. Okay, we've got this bag containing 7 identical balls, numbered as follows. A game consists of randomly selecting 2 balls from the bag without replacement. The rules of the game are the player wins $5 Australian if both balls are numbered with even numbers. The player wins $10 Australian if the total of both numbers is even. The player does not win anything otherwise. Right, so this first part of the question, does it have anything really to do with this information?
No.
Not particularly, no. Okay, so we're looking at picking an even or odd number, okay? Now everybody did this well. If I pick a... Are we replacing the ball, by the way?
No.
Okay. So if I pick the first ball is even, the probability that the next ball is even is going to be?
2 out of 6.
2 out of 6, good, because there's 2 even balls left out of then a total of 6. These 2 probabilities have to add up to 1, so this has to be 4 out of 6. Now, if you didn't simplify them, it's fine, it doesn't make any difference. If I pick an odd one out first, I would still have 3 even, right? Good, so it's going to be 3 out of 6, which is a half. I'll just leave it as 3 over 6. 3 over 6. Okay. Easy enough, nice big marks. Right, this is kind of similar to these questions that we talked about before in probability. Given that the player won $10 Australian, show that the probability that the first ball selected was even is 1/3, okay? So given he won $10 Australian, so if he won $10 Australian, the total of both numbers is even, okay? The total of both numbers. So that means what?
It's a 4.
Right.
So it's the probability of the first ball he chose was even, plus the probability that the second ball he chose was even over over the probability of the second ball being chosen as even.
Okay.
Is that how it works?
It's right,
Yeah,
so
we
it's
use a given.
given. Okay, so let's actually type this up. So we want the probability that the first ball is even. Given. And I'm going to use given that the player won $10 Australian. And in order to win $10 Australian, both balls have to be even. Yep.
Yes.
Okay. Because it's the total that's even. An even plus an even is always going to be even. Or odd plus odd.
Oh, okay, yeah.
I've got this given. All right. So first, let's work out the probability both are even. How do we do that?
Even plus even.
So I'm looking along this line here. And I'm moving in this direction along probability tree.
Yep.
I'm not adding.
So you're
Multiply.
I'm multiplying. Okay, they're independent events. So if, yeah, if it's even, I'm multiplying. So it's, I'll do my 3 over 7 multiplied by 2 over 6, which equals 6 over 42. Yep. The probability that both are odd. Cool. 4 over 7 times 3 over 6, which equals 12 over 42. So the probability that both are even or both are odd, how do we work that out? You add them together, right? And they're with the same common denominator. So again, 18 over 42. Right, now we still need to work out this given probability. Now, if I go up to my formula booklet, I'll bring that up in a second. I have this formula, conditional probability. What does this say? If I have to read this out?
Probability that A happened given B.
Right, good. The probability of A happening given B has happened is equal to the probability of A and B happening over the probability of B, okay? We have all this information, okay? So if I go back, if I take this, copy it, let's put it down here. This is equal to the probability. First ball is odd, and
Is that right?
Yeah.
Would you look at what?
Gunshots.
No, I don't want to see.
Get down, get down. Sorry, who's the car here?
it's okay. Okay. The probability that the first ball is even. Okay, so this is where you kind of have to think quite clearly here, divided by the probability okay, so that's just taken from the formula, okay? Now this, the probability that the first ball is odd and the total is even or odd, okay? Now for that to happen, sorry. Did you get down to here so far?
Yes.
So, just to kind of go back, okay, because I want to clarify it, even just for myself, we want the probability that the total, given that the total of both numbers is even, given that the total of numbers of both numbers are even, total of both numbers, that means they have to be both odd or both even. Find the probability that the first ball is even. Okay? So what we've worked out here is the probability that both are even. So that's picking an even number, then picking another one. Then we've worked out the probability that both are odd, so picking an odd number or picking an odd number. Then picking either of those happening, okay? So this one or this one. So that's why we've added them together. Okay? Now if the first ball is even, what's the probability of getting a first ball that is even and the total being even?
6 out of 42.
6 out of 42. Okay, we're looking down this line here. Okay? So it equals 6 out of 42. And then we need to divide that by what's the probability that both are odd or even? 18 over 42. So we've got
What about the both are odd?
this bit. That's what we've got here.
That the first ball is odd and total. is
Sorry,
even.
that should say even.
Oh.
My bad. Sorry. First ball is even and total is even or odd. So if that's
Okay,
the
so
case,
you would have to add So would it be 18 over 42 there? 'Cause
so this part, 18 over 42 refers to this bit here. Okay? I've got a divide sign in here, okay? It doesn't want to fit in the same line, which is a little bit annoying. Okay? This bit
Oh, okay. All right.
refers to the 6 over 42. Alright? So whenever I divide these, I get 6 over 18, which is the same as 1 over 3. It's the language in this is confusing, okay? Because it's player wins 10 if the total of both numbers is even. So let's okay, so just to kind of, does everybody see where I'm getting this from? That is from that formula, yeah? Given that the total of both is even, find the probability that the first ball is even. So it's the first ball is even and the total is even or odd. That can only happen, first ball is even and the total is even or odd along this line.
Okay.
Yep. And then divided by the probability that the total of both is even, which is what we've worked out here. Yep, all right.
Real quick question. I just wanted to say, why is it that it's the total of even or odd? Total is even or odd.
Okay, because it says that they will win 10 Australian dollars if the total of both numbers is even.
Yeah.
So the total will be even if you add together two even numbers. It'll also be even if you add together two odd numbers.
Yeah, but what I was saying was that it seems as if you're trying to say that the total of two bowls, it either has to be even or odd. Not that the two numbers that you add together are odd, or two numbers that you are adding together are even. That's what I'm trying to say.
So say it one more time.
When it's written as total is even or odd, it seems that it implies that it's saying that the sum of the two bowls can either be odd or even.
Oh, right, I
Not
see what you're
just,
saying.
yeah.
So that's what I wrote here, yeah.
Yeah.
First ball is even, yeah, sorry, that's my bad. Take that out. Yeah, sorry, yeah, you're right. First ball is even and total of both is even. It's just the way I had it worded before, it wasn't very clear. Ellie, come on. Okay. Right, three balls numbered A, B, and C are added to the bag, arranged in this order. Given that the median is 5, show that B is 7. So, what did we do here? This wasn't too bad, actually.
I kind of just said that the middle number. I don't think I said the average or the middle number between 3 and 7 and 5.
Yep, so the median is the middle, and the middle number in ascending order. That lies between
3 and 7.
In this case, 3 and 7.
3 and 7. So the middle number between 3 and 7 is 5. Okay, you could even say 3 plus 7 divided by 2. Okay, let's just find the middle number, okay? Given that the range is 34 and the arithmetic mean is 2.7, find the values of NC. Right, what is range?
The
Largest
largest
number,
one is
take away the small.
Okay, so what's the largest number?
C.
Right, what's the smallest number?
A.
So C take away A equals 34, so you get a mark for doing that. Oops. Okay. What about the arithmetic mean? How do you work out the mean?
All the numbers added together divided by the numbers.
Yeah.
Right, so all the numbers added together. Okay, and again, this was not done too badly, it's just that there were some mistakes, okay? Silly mistakes. So we've got A, add negative 12, add negative 9, add 0, add 3, add 7, add 7, add 10, add 15, add C.
How would you add 2 7?
Is
Oh,
it not-
okay, never mind.
Yep, 2 7. Yep, because we're told one of them, yep. All divided by 10 equals 2.7. What should I do next, do you think? Thoughts?
You could, I would say add, not add, yeah, you could, always substitute 34 into the equations.
If we have a C minus A in here, we
Yeah.
could, but we don't have a C minus A. I've got two equations, two unknowns. Can we tidy this up a bit? Like, look at the state of it. Let's tidy it up.
Oh yeah.
How do we tidy it up? Come on.
I don't know what to go.
Right, let's add these things up, okay? So I've got, I'm going to bring this up. So I've got minus 12. Take away minus 12. Take away. Okay, why can't I use this? Is this safe to do it each time? Minus 12. Take away 9.
You could just also click on the
Add 3. Add 7. Add 7. Add 10. Add 15. Equals 21. Yep. So I've got A plus C plus 21 equals 2.7. Looks a bit nicer. Oh, I forgot the divide by 10. What could I do next to tidy it up a little bit? Right, multiply that by 10, so we've got A plus C plus 21 equals 27. Next. Good, which gives me. Good, so we've got A plus C equals 6. Now what? Okay, you're almost there. You're sitting on like 4 marks. 6.
Shouldn't it be 5?
A plus C is 6. 27 take away
No,
21.
enough for that. For the 2 7s in there. Because we already know that's B equals 5.
Oh, you could do like A equals 7. A
B
equals
equals
6 minus C.
Oh, okay. Oh, yeah.
Yeah.
Yep, so we're going to use one of these to substitute in. So let's take this one. Okay, stop. Okay, and let's rewrite this as what? C equals what? 34 plus A, right? And we can substitute that into here. Okay, so it's going to be A plus, good, equals 6. So I've got how many A's? And then keep going some more, you're doing good. Which is negative 28. A equals negative 14, good. And then substitute that back in up here. So C equals, I'll just write it out. So C equals 20. Okay, now in this I would not probably use the equation editor, okay? I would type it out because it's fairly straightforward and there's no awkward symbols or anything, okay? It's easy enough to read. Does that make sense? Well, most of you did that pretty well, it's just making sure you get all the info down. Again, the most difficult thing in this question was probably, to be fair, that first probability part. But this is like so far, what do you think? Doable?
Easy. Yeah.
It's weird. Now that I'm looking at it again, I understood what I was supposed to do before you started the question, but like on exam day, I could not remember.
All good, everybody got down? Lily? You alright? Alright, let's quickly have a quick look at this next one, which most people just left out. This is the stuff we did at the beginning of the year. Right, so we've got the diagram shows the triangle ABC. The length of BC is 3 root 2. Angle ACB is pi over 3 radians. Angle BAC is pi over 4. Show that the length of AB is 3 root 3. Okay, you all pretty much knew you had to use what method? Is this a right angle triangle?
Yeah, it's Pythagoras.
Pythagoras?
Wait, no,
Sorry,
No.
trigonometry.
Trigonometry, okay, but like just normal SOHCAHTOA?
Yeah.
No,
We get to use
sine,
no.
cosine rule.
Right,
No.
sine rule or cosine rule. Which one are you going to use?
Sine.
Sorry.
Okay, good. Because?
Because you only have, cosine rules,
Yeah.
you have like two,
Two sides and an angle in between.
Yeah,
Good.
sine rule.
Excellent. Right, so you're using sine rule. So, we've got the sine rule we were going to have. Who can tell me what to write down? This is what we're after, by the way, AB. AB over, I'll start you off. I'm going to use the equation editor to make it look nice.
AB over sine pi over 3.
Sine pi, awkward, over 3. Good. Okay, equals 3 square root 2 over sine pi over 4. Good, just using the sine rule. Smart, did you do that? In your test, you remember?
I'm pretty sure. I don't know.
That's good, right. Next thing. So what we're trying to work out is AB. Most of you actually did this, as far as I remember. What is sine of... This is where I just got a bit sad. What is sine of pi over 3? What does that equal to? That's an exact value. That is sine of... What is pi over 3 in degrees? What's sine of 60?
No,
No.
it's not. It's
It's 2 over.
Sine of 60 is root 3 over 2.
Oh, okay.
Okay, look, you need to remember these, okay? By using those triangles. We also know that sine of pi over 4. Pi over 4 is how many degrees? Pi over 4 is how many degrees?
45.
45. What's sine of 45 degrees?
1 over square root 2 or 2 square.
Which is it, Samara?
Square root
Yeah.
2, yeah.
Okay. I'm just going to put all this in now and then finish it off. Okay, so I've got my formula. I've got my exact values. Now all I have to do is substitute these in, okay? Which I can see would be a pain because it just doesn't look very nice, does it? So I've got AB divided by root 3 over 2, yep. If I'm dividing by root 3 over 2, what's that the same as? Timesing by 2 over root 3, right, good. So I've got, let me go back to my equation editor. AB multiplied by, you just said, 2. AB multiplied by 2 over root 3. Good, Lily. That is equal to, now if I've got 3 root 2, and that is being divided by sine of pi over 4, which is being, so that means we're dividing by 1 over root 2. That's the same as multiplying by root 2 over 1, or just root 2, yeah? Is everybody okay with that? That's just our fractions and substituting those exact values in. Right, let's tidy it up. I've got AB. I'll let us go in just 1 second. AB multiplied by 2 over root 3 equals... What's 3 times root 2 times root 2? Come on.
3 root 2, well,
3 over 2.
3 times root 2 times root 2.
that'd be 3 root 2 squared, right? And then that's just 3 times 2,
Which is?
which is 6.
Right, root 2 times root 2 is 2. 2 times 3 is 6. Right, so AB is equal to... What do I have to do? Bring the root 3 up, yes?
Yes.
So it's going to be 6 root 3. So I want to like this. 6 root 3 divided by 2. And that simplifies to 3 root 3. It should all be there. Again, the difficult thing with this is if you're writing it out, it would be a lot easier, okay? But we don't have that luxury, okay? You have to be able to kind of think on your feet, and if I'm dealing with these fractions, what exactly am I doing? Even, this is actually only worth 2 marks. So you get that first formula down. I'll put it back in a second. If you get this down, that first line, you get 1 mark. If you write these 2 things down, you get the other mark, okay? So basically, like, that's all you needed to do with that. Okay, and then if you wrote basically the answer, because you're given the answer, that's it, you're done, okay? So you only needed to know these exact values and write that first line down, okay? All right, well, we're over halfway. That's, any questions so far? Okay, we'll finish off tomorrow, okay? And has everybody got what they need? Jen, you got everything?
And can we go over grades tomorrow?
Oh, yes, you can have these back. Let me just, can I quit out of this?
Yes.
Quit.
You just go to invigilator. You go to the assistant.